Computing and AI enable us to process bits and information. AI vastly amplifies our pattern recognition capabilities and our problem-solving skills. And robotics and nanotechnology will enable us to program molecules and matter. We don't have atomically precise manufacturing yet, but when we do, it will alter our relationship to atoms and matter, like the computer altered our relationship to bits and information. These technologies are altering the playing field, completely disrupting the playing field. They're not just game changers. Let me explain the difference between linear and exponential thinking to you, because that turns out to be the key to understanding how rapidly these technologies are advancing. If I take 30 linear steps across this stage, you can predict where I'll be, 30 meters away. But if I take 30 exponential steps, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, etc., 30 steps, I'll be over 1 billion meters away. And just to inform your exponential intuition about that, it's 26 times around the planet. But we can do something more than macro-scale manufacturing. Richard Feynman pointed to the need to manipulate individual atoms. And in fact, 30 years after his 1959 talk at Caltech's cafeteria, Don Eigler and colleagues did succeed in spelling out IBM with 35 xenon atoms on a nickel substrate. 30 years. Molecular robotics and manufacturing, atomically precise manufacturing, hasn't fully happened yet, but we're nibbling at the edges. And when we get it, we will have the ability to specify 3D structures that are small or very large. The maturity is R&D, it's not a typical VC horizon yet. There was some controversy about whether this was possible or not. A number of us testified at the National Academy of Sciences workshop on the feasibility of molecular manufacturing. And in 2006, they came out with this report called A Matter of Size, indicating that yes, indeed, molecular manufacturing would be possible, and we need a roadmap. And we're working on a roadmap, in fact, published one the following year. Redwood trees are an example of solar-driven molecular manufacturing that cleave carbon from carbon dioxide, synthesize glucose from the carbon, polymerize the glucose into cellulose, and that makes wood. And you can see you can make very big things out of that. Convergent assembly takes us from the nano size to the macro size in 30 steps. Zyvex had been working on that. And manufacturing costs will eventually be the cost of raw materials, the cost of energy needed for manufacturing, and the cost of design or intellectual property. So we're going to see a real revolution in manufacturing. You may recognize this as the garage that HP was born in. Assuming zero new technology breakthroughs, I believe that professional work is ripe for disruption. People often ask us, how do we deal with that? How do we think outside the box? My answer is, there is no box. We all live in alternative mental prisons. The function of education is to blast us out of our mental prisons and get us to see what the possibilities of the future are. And that's what leads me to tell our students that sustainable human intelligence requires mathematical, ecological, and ethical literacy. That's a longer conversation. We can have a conversation about that in the breakout session. I encourage you to build the future boldly, but do it responsibly. Remember, our skies are not the limit. Thank you very much.